Hi everyone, you're looking at an update, and what I've done here is we had this single C-core, and I decided let's go and put another C-core cross on basically 90 degrees on this angle here, so making a cross, and this is what I've come up with. And that C-core that I added there, I've obviously cut it compared to this is the original length of the core of the transformer, and machined that nicely to the perfect air gap here again with that. And I also have an air gap right here in between this C-core and that C-core, so the fluxes don't mix as well. And sorry for the cheap welding job, but that's I'm not a welder, but it's good enough to do a demonstration. And the idea of doing this is basically now we have, for the same RPM here, we now have double the effect here, and it changes the waveform quite a bit. And I'll show you. This is my YouTube video here. This is what the scope waveform looked like, and I'll flip it over to the new waveform looking at the oscilloscope in a second when I start this, and you'll see quite a difference. So we had these peaks and this dead space here, and again this peak, and now basically we're going to just have this space here is going to be another peak. So it's looking much closer to a sine wave now, with it being double like that. And the other thing that I was able to do is reduce the speed here by one down here. I was up here to get that effect of basically when it goes under load, that it gives this impression of reducing the power to the prime mover. So let me start this. Oh yeah, what I've decided to do as well is I've got a Variac hooked up now to this is basically an induction motor, and what I'm doing is I'm dropping the voltage on the induction motor to a point where it's going to be a lot less power going into the induction motor. This is the power going into the Variac. There's always about close to 10 watts just being wasted, it being on, and that will be the power actually coming out of the Variac going to the prime mover, that induction motor turning the drill press. So that's really what our true power will be consumed by the drill press motor, and basically it'll be about 10 watts less than what you see here. So that's what this setup is, and now when I start it, it won't be strong enough to start the shaft turning by itself, and I'll just assist it and then it'll take off. So once the induction motor gets up to speed, then it's working on its own. So that's what's going to the Variac, and this is what's going to the induction motor. So we're down to 83, even 82. It'll probably keep dropping a little bit as the bearings get warmer. The other thing too right now is the 1 ohm load is off load right now, and if you remember the previous video, it was very loud sound. That's actually come down quite a bit by having this double amount of C-cores turning on the surface. So there is what we had, and I will click now to show you what it looks like now. So this is what the waveform looks like now. So much more like a sine wave. So now I'm going to put it on load. So it's now on load, and our prime mover has gone down to about 78 watts. And what I'll do now is I'll take it off load. So that's 78 watts. Now it's off load. You still hear the sound a little bit, a little difference. And now we're going back on load. Now if we look at our scope here, and we get that's what our waveform looks like across that 1 ohm resistor. It's a much cleaner sine wave. And if I spread that out a little bit more, we can have a better look at it. And I'll compress that, give more samples here. We'll try to get a power reading here as far as volts RMS is concerned. So we have basically 2.3 volts RMS there, and that is actually 5.3 watts being dissipated on our 1 ohm resistor. So that again is our power to the prime mover right there, 77.3. Now it's off load, and there you go. So that's the small update for this time, and thanks for watching. Bye now.